Okay, this is lesson 10.1, the sequential counting principle. 10.1, the sequential counting principle. I'm going to read several examples for you. That way you could adjust your way through the lesson looking at some of these examples. If a state wants each of its license plate to contain 7 different digits, how many different license plates can it make if any of the digits 0 through 9 can appear in any of the, it should say 7 positions here. It should say 7 positions. Okay, so if you think about it, the license plate has 7 positions, 3, 4, 5, 6, 7, and it wants it to contain 7 different digits. The digits from 0 through 9. If you think about the digits from 0 through 9, you count 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. How many numbers are there here? 7, 8, 9, 10. There's 10. Therefore, in the first slot of the license plate, you have 10 different numbers to choose from. Since you already chose one number, you have 9 different numbers to choose from. Then you have 8 different numbers to choose from. Then you have 7 different numbers to choose from. 6, then what? 5, and then 4. So if you multiply this, you would get 10 times 9 times 8 times 7 times 6 times 5 times 4. That would give you a total of 604,800 different positions. Let's look at example 2. Example 2 says, a local pizza place offers 4 choices of size, 4 types of crust, the choice of either round or rectangular, and 7 toppings. How many one-topping pizzas can be ordered? So, let's see. There are 4 choices of size. Okay, so we have 4 choices of size. Then, we have 4 choices of, how many choices of crust? That's right, 4 choices of crust. And then the shape is either round or rectangular. How many choices do you have there? 2 shapes, or 2 shape choices, right? And then toppings. Oh, sorry about that. Toppings. How many toppings do you have to choose from? You have 7 toppings. So, if you want to find out how many one-topping pizzas you can order, how many choices you have to order, you would actually multiply all of those values together. 4 times 4 times 2 times 7. That'll give us a total of 224 one-topping pizzas. Just as we discussed in class. So, what you're doing is, in essence, counting the choices and multiplying. If you look at your textbook on page 660, it tells you in the little green box the sequential counting principle. Let's look at this next question, this next example. This is saying a local band is putting together a tour of 6 cities. If the band has a choice of 10 cities, how many different tour schedules can they arrange? So, think about it. The tour, it's stopping at city 1, then stopping at city 2, then city 3, then city 4, then city 5, then city 6. So, we want to know how many different tour schedules can they form. So first we think about what are the total cities available for the tour schedule? There are 10 cities. So on the first slot, we have 10 to choose from. Since we already chose one, how many are left? We have 9 cities to choose from. There's 2 out. So now how many do we have to choose from? There are 8 cities to choose from. Then what? 7 cities to choose from. Then 6 cities to choose from. And lastly, 5 cities to choose from. And once again, using the sequential counting principle, we multiply 10 times 9 times 8 times 7 times 6 times 5. That'll give us 151,200 arrangements. Sorry, I was putting dollars. Arrangements. The last example here says, at a high school cafeteria, dinners can be chosen from one vegetable choice of 4, so we have a vegetable. Then we have 1 meat, 1 bread, and a dessert. They want to know how many meal configurations are possible. Well, how many vegetables do we have to choose from? It's 4. How many meat choices do we have to choose from? 3. How many bread choices do we have to choose from? 4. And how many desserts do we have to choose from? 2. That would give us 4 times 3 times 4 times 2. That would give us 96 possible meal configurations. See, in essence, what you're doing, it's like saying you have 2 colors, red and blue, okay? And let's say for, let's say a scarf, okay? Let's say you have a scarf. You either have a red scarf or a blue scarf. And then shoes. You have a yellow and, let's say, green, okay? Very colorful here. These are your shoes. Okay. And we want to know how many different configurations. Well, look, you could take a red scarf with yellow shoes. You could take a red scarf with green shoes. Or you could take blue scarf with yellow shoes. Or you can take blue scarf with green shoes. So it gives you a total of 1, 2, 3, 4 configurations. Well, that's expected because I have 2 choices here multiplied by the 2 choices here, which gives me a total of 4 configurations. And that is lesson 10.1. This is a little supplemental video. I hope it helps you. Thank you.